Hello everyone, I'm Paul and today we're solving problem 3531, count covered buildings. This is medium and here I will show you my thought process and efficient solution. We are given a positive integer n representing the size of a city. So if n is 5, here you have the visual representation of the city. And we are also given a 2D grid buildings where each element corresponds to some building in within this city. We need to return the number of covered buildings, and a building is covered if there is at least one building in all four directions. For example, this building is covered because we have one building in all four directions, and this building is not covered because we are missing three buildings here. We only have one building below. So in this case, we return 1 because of this building. The main observation here is the following. Let's say that we are standing at this building. We know that this is covered if and only if it's not part of any of the four bounds. So if we take every building in this city, these are the four bounds. If we are standing here, we have one building to the left, one to the right, one above and one below. So this is not part of any of the four possible bounds. That's how we know that this is covered. Now, of course, that we can't iterate every other building from each building because that will require time complexity of big O of n squared, and here n can be up to 10 to the power 5, so this is too much. We need to think about something else. So we can have two maps here, one for rows and one for columns. And now we need to fill these maps. Let's say that we are iterating this from left to right, and first we are here. We go to rows at 3, and there are different possible solutions here. One is we can store every building in the row. Actually, we are storing the x coordinates for every building in the row. So after iterating this entire thing, row 3 will contain 1, 3, and 5. These numbers correspond to the x coordinates of every building in this row. Now, if we sort this array, we know that everything that's in the middle is covered by these left and right buildings. Similarly, in this map, we can store columns. So in column 3, we have an array with the y coordinates for this column, meaning 2, 3, and 5. And now we can sort these two, and we know that everything that's in the middle is covered by top and bottom. So we know that the coordinates 3, 3 correspond to a building that's covered. This corresponds to this building. And this is fine, you can solve the problem by doing this, but the big brain solution is the following. Let's say that we are at this row. Remember that everything that's in between these left and right bounds is covered, so we only care about knowing where these bounds are. We know that everything that's in between is covered. Now, what we can do instead then is we can use this map or array to store rows as keys, and the value for this is an array where the first element corresponds to the minimum x coordinate, in this case 1, and the second element corresponds to the maximum x coordinate in this row, meaning 5. And we can do something very similar with columns. Let's say that we are standing at this column, so we add here 3, and the value for this is an array where the first element is the minimum y coordinate for this column, meaning 2, and the second number is the maximum y coordinate, meaning 5. So then we can iterate buildings again, and when we find something like this, well, we can take the x coordinate and check if it's in within these low and high bounds, and 3 is in between 1 and 5, so we are good to go. And we are also checking if the 3 for the y coordinate is in between 2 and 5, and it is. So we are also good to go. Given that we meet these two conditions, we add 1 to the result. So we are iterating this from left to right in order to build these two maps. That's how we get these two maps. Then we iterate buildings again to check if we have buildings that are covered. Every time we find one, we add it to the result. And finally, for this input, we return 1. Here, time complexity is big O of m, where m is the amount of buildings, because we are iterating this 2 times. And space complexity is the same, because we are storing the information for every building in these 2 maps, and every time we are using an array of only 2 elements. So each of these has constant space. So overall space complexity is the same. Now, with this in mind, let's go with the code. We need a map for rows. So here we use a default dictionary with a default value of an array with n and 0. We are using index 0 for the minimum number, so that's why we start with the maximum number, which is n. And index 1 is for the maximum number, so we start with the minimum possible number, which is 0. And if we want this array to be unique, here we need to use a lambda function. And we are doing something very similar for columns. So this is columns, we use exactly in the same. Okay. Now for every column and row in buildings, first we say rows at the current row 0, meaning the smallest element is the minimum between row 0 and the current column. Similarly, index 1 is the maximum between index 1 and the current column. And now for columns, at the current column, index 0 is the minimum between columns for the current column at index 0 and the current row. And we can copy this. We know that index 1 is the maximum between index 1 and the current row. So now the result is initially 0, and we can iterate every column and row in buildings again. This is the second for loop. And now we're checking if the current column is in between the minimum value for the current row and the maximum value for the current row, and if the current row is in between the minimum and maximum values for the current column. So if this is true, we add 1 to the result. Let's code this. If rows at the current row 0 is smaller than C, and this is smaller than rows row -1, and column 0 is smaller than row, and this is smaller than column -1, here we just add 1 to the result. Finally, we return result. So this is the entire code. I think this is right. Now let's submit this. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.